Gabe, you can't talk about anybody. Excuse me, whose phone is this? We don't plug in their phones in my class. Whose is this? Lana's? What is yours going to?
30.
30? Thank you. Charge in other classes, not mine, please. Alrighty, I don't like having wires out, it's how people trip. Someone already broke the projector today. Alright. So let's look at the bell ringers. Sorry that took me longer than expected. There it is, you don't need it. At least for this. Really quickly, because a couple of students have asked about this. If you hit the pi symbol on your calculator, so hit the little pi symbol down in the bottom left-hand corner. What pops up?
A pi symbol.
It's in the bottom left-hand corner. It's above the comma. Does anyone see a symbol that we might need for this unit? Theta. So, this is the Greek letter theta. Theta. No, you didn't need it. Someone was just, I've heard multiple people ask for it. Theta. Theta. T-H-E-T-A. Huh? Is it used at the university? Universally? I mean, yes.
University. Isn't that like the same?
Is it used exclusively at colleges? No. It's a Greek letter. They use Greek letters in fraternities and sororities on campuses.
What university did you go to?
UA.
Okay. And then what kind of thing they did for math? They had to go to like another school.
I don't know what you're talking
You don't know what you're talking about, just be quiet. What?
I wish I could help you, but look.
You're thinking about
Theta is not a name.
fraternity houses.
That's what I just said.
That's what you're thinking about.
I know.
That's what it is.
No.
That's what you're
Stop. Matthew, if you can think about it afterwards or later, if you can think about it later, let me know after class. Alright. Hey, I need everyone's attention because we got to get through this. We got to get back to what we were working on yesterday. That's not what I need. I need review. Okay. So the first question is, what is the tangent of beta? The majority of us answered b divided by a. I don't even know what to say about that. First off, because I know you can type this into the calculator, but what is the first thing that you should do to earn maximum credit when it comes to telling me what the tangent of beta is?
Details.
So the tangent of b equals side opposite b divided by side adjacent b. Now, I will point this out. No. Okay. I'm saying on understanding checks and tests and things like that, you need to write all this out, right? But I will point out, no one did this, but could you have written the tangent of b equals whatever the ratio was?
Yeah.
Should you have probably done that? Typed out tangent of b equals. You could have done that. Okay? So what side was opposite b? Now, we need to clarify, what do we mean by opposite?
The opposite of the
Across from. I need y'all to remember this. If we are dealing with this angle B, opposite means across. Literally start at that vertex and go across from that vertex. So this is my opposite of B. Side adjacent Wait, why is it A and not C? Because remember, Josh, what does the word adjacent mean?
Next to.
It means next to, right? So why is A adjacent and not C?
Because hypotenuse.
Which one's the hypotenuse?
C.
Small c.
C. Small c.
I see.
Now, I don't see a little right symbol here, so why is this C? Or why is this C hypotenuse?
So this is the longest side.
It's not just because it's the longest side.
Because it's 90 degrees.
There's 90 degrees.
Okay, even though there's not that right angle symbol, it is what angle measure? 90.
It's a right triangle, so it's gonna be 90 degrees.
Well, but also, I told you that was 90 in the thing. So even though it doesn't have this symbol, we know it's 90, so that's my hypotenuse. So if that's hypotenuse, we can finally finish filling this out, and that is my adjacent to B. So the tangent of B is opposite divided by adjacent, or B divided by A. Label everything, it'll help you significantly. Hopefully this is a good little refresher. Last question from the bell ringer. Which trig ratio results in B divided by C? Weird, I don't think the number 11 is anywhere up there, but okay. So, really quickly, we need to talk about this. Is SI supposed to be sine?
Wait, what?
No, it's supposed to be c.
7 different people put SI. Do we mean sine?
No, we put some.
Yeah,
Good sign.
when you put it, it'll take it off. It'll say error.
It says error? Huh. I wonder why it said error.
Because the real word is sin.
No.
Or is it suppress the trig and
So let me send this back out and let's see if we can fix our issue.
I don't know what it's going to be.
Okay? Now, 2 things.
Wait, why did it change it?
So it sounds like some of us messed up in putting it in our calculators, misunderstood it. So can I see this real quick? I mean, we came back to you. Let me check something. Okay. So I need y'all to do this for me. I want everyone, I'm not saying it has to be signed, but I want you to I want you to go to trig, so hit the trig button, and then pick one of the trig ratios, sine, cosine, or tangent, I don't care which one. And when you do that, hit enter. Don't put don't put any angle in there, just have sine and it should have parentheses, and then hit enter. What does it say?
Error.
Or cosine's fine. It says error. Because a trigonometric ratio is always sine of a what?
Angle.
Angle. If you don't put an angle in there, it is going to tell you error. Trig ratios are always sine of an angle, cosine of an angle. So you need to identify sine or cosine and of an angle. Talk about it within your group. Figure out which trig ratio you want to do as a group. Let's go. You got 60 seconds. You can't just say sine. There's something you're missing. Tell you error if you put it in sine. Sine B?
Sine B?
You don't think sine B?
Sine B, good answer.
Sine B?
Yeah,
Is that what you thought? So Charles, give me a blank look like I have no clue what you're asking. Huh? Say it again. Have you talked with your group?
I'm about to say this.
So you say cosine of C. There's C, right? So tell me why you're thinking cosine of C. No. Why are you thinking cosine of C?
What's the
I see sine of B over here. And you need to figure it out. I can't help you if you're not thinking about it. You just leave it as it'll understand that the B is the English is B. It might make it lowercase, but it'll understand. Wait, can you do the cosine? I think you mean cosine with different angle.
Move, man.
No. It doesn't have to have an angle measure. It just has to have an angle.
What was that?
like the letter you could use.
Yeah, that's.
So,
Oh, it's not.
because, why do you have to put
See, last time you do that, I put my
an
meat.
type in something, this I
Yeah, I ain't funny. I'm
Oh, is that what, so it did,
No, it's
so it doesn't understand it as an operation then, it just thinks it's a bunch of variables next to each other. That's the issue. Okay, so that was the issue, is that it just saw variables, it did not see the trig ratio.
And I know my dad.
So right,
For a
it
long
needed a
time.
trig. Thank you, thank you. Alright, so I'm gonna collect it, see where we are. Hopefully we all have at least an answer by now.
Yes, sir.
Alright, so now let's look at it again. What did you say?
He said MF.
I feel like I have an idea who it was, but I don't fully know, so no one's getting written up, but you need to watch your language, whoever that was. Okay, so the majority of us are thinking sine, and the sine of angle B. We all good with that?
Yes, sir.
Okay, let me ask you this. Huh? Okay, so really quickly, I know, listen, the calculator doesn't like uppercase letters for variables, so it just automatically made it lowercase. I know, because I saw everyone putting capital B, you're good, okay? But let me ask you this. Could I have done the cosine of angle A?
Yes. Yeah. Wait, no. Oh, yes.
I need everybody's attention. So everybody, almost everybody, said the sine of angle B. Which if here's angle B, what's opposite angle B? Side B. And what needs to be in the denominator? The hypotenuse, which is C, side C. Is that the ratio right here? Yep, we're good to go. But I also want you to notice the cosine of angle A. Joe, why are we talking? I'm teaching important things. You need to pay attention to this. Here's the cosine, here's A. How would I calculate the cosine of A? Adjacent, which is divided by? You can have multiple answers in a problem like this. There are actually multiple ways to get those trig ratios. And the reason why I bring this up is one of the biggest things that gives students trouble when it comes to trig ratios is they look and they're like, I have no clue what angle to use. It's okay, you can use either of them, as long as you know what the angle measure is. And so that's what I want you to start building a level of comfort with, is just looking at which angle is my reference angle. Because then I can figure out the trig ratio based on that reference angle. Rose, did you have a question? I thought you had your hand up. Alright, y'all ready to get started with today's lesson? I guess. Now I need you to hear me very clearly on this. Today is the last day that we are going to work on this using the trigonometry to solve right triangles. This is the last day we're doing it in class. So you need to work efficiently with your small group. That is the sheet we started on yesterday.
Yes, sir. A two-tone.
Okay? Because we have two major topics still to cover. The special right triangles, which are specific right triangles that we use regularly in trigonometry, and then we still need to talk about circles before we test next week and take our exam next week for some of us.
I'm not ready for that.
Okay, because, listen, we are going to have a test next week because I have to test you on trig and circles. And I have to do that because I don't know for sure, I think some of us are going to be exempt. So I have to have a test to make sure everyone's learned this content before the exam in case anyone's exempt.
Oh, so you can be exempt.
I don't know for sure, but I'm planning on it that some people can be exempt. If no one can be exempt, then I won't have a separate test. Alright.
What you have to do to be exempt, you have like a meeting.
I have no idea, don't worry about it right now, I gotta teach you some math. Alright, so remember, here's our objectives. We want to be able to use trigonometry and the Pythagorean theorem to solve a right triangle. We talked about this yesterday. What does it mean to solve a right triangle? You have to know all side lengths
And angles.
and angle measures. You have to be able to do both of those things. To solve a right triangle, you have to figure out every side length and every angle measure. And we're only going to do a couple of these where we solve the right triangle all the way. The rest we're just going to use trig ratios to solve for a specified value.
Mr. Kenny, can you repeat that?
You hear me getting information from two different people? Are you getting the definition? Kyson?
What did you just say about it?
Solving right triangles?
All side lengths.
If you are going to solve a right triangle, you need to figure out all side lengths and all angle measures. And what are we going to use to find all side lengths and all angle measures? Pythagorean theorem and what else? Don't everybody say it all at once. In order to solve a right triangle, we're going to use Pythagorean theorem and trig ratios. Trigonometric ratios or trig ratios. Okay? And Ren, did you say trigonometry? That's trigonometric ratios. That's just the adjective to describe the type of ratios. It is also called trigonometry. That's the noun. Trigonometric ratios is the adjective, and just talking about the ratios. So I want us to do this right now. Numbers 1 through 4, solve for x. Numbers 5 through 8, solve the triangle. I don't know why so many of us are talking. And then if we get to 9 through 11, we will just solve for x again. So what I want us to do to make sure we all understand how to approach this problem. Yeah. Actually, I want you to work on number 3 within your small groups to get started. So, numbers 1 through 4, what is the only thing we're doing?
Solving for x.
Solving for x. I want you to take 30 seconds right now, Brandon. 30 seconds right now to think silently and on your own to figure out which trig ratio you're going to use to solve number 3. After that, I'm going to give you a chance to talk with your small group to see if they agree with the trig ratio and for you to set it up. 30 seconds independently. Go. Alright, your 30 seconds are up. Let's start talking within our group. Y'all, talk within our group. See which trig ratio we're going to use to solve this right triangle.
Number 3, right?
Number 3, yeah. Put that away right now. Reflect on that later. I need you to work on this sheet. Hands away. Get your head up, dude. You can't learn like that. Head up.
Unless someone had took a picture.
It's building off what we did last week. But I want you to look at number 3. Show me what
Both of them. Of my granddad's block.
you're not giving
I know, right? One of my granddad's block. What's your granddad's
number
block?
3. Which angle are you giving?
How you know? I told y'all unload that machine.
Which side?
You down the hospital.
To that angle.
What are you down there?
And is that your hypotenuse, your opposite, or your adjacent?
My granddad died.
Is that just 23 that is
That
next?
was my mama. I don't know what I had. Yeah, my mom and dad. The one that died was
You have to label and identify it. You start
My dad
labeling
died.
it.
My dad died. And I don't even know my dad died.
Thank you, thank you. All right, so let's start with Claire. What trig ratio did your group say that we should deal with or use? Sine? Okay. Sine of what angle do you think we'd be dealing with? Okay. So let me ask y'all this. Can we do the sine of x?
Yes.
No.
Not at all.
London, why do you say no? That y'all are in the same group together. Did y'all talk about this?
Yeah, but we didn't know the answer.
Okay, so but y'all should have at least like ruled some stuff out. You said no, we cannot do the sine of x.
I thought you only used
A, B, and C were always the what?
Reference.
Reference angles.
Workaround.
Okay, so y'all pay attention to this.
Pay attention.
So can I do the sine of x if I want the sine of a reference angle? Why not? Okay, so Claire knows how that x is a side, right? It's a good try, but I want y'all to notice, and this is important, right? I like y'all to make mistakes. That's okay. We just have to recognize, ooh, that can't work because that's not an angle. Ari, what you thinking?
Sine of 30 for 23.
Oh, let's say that a little bit louder for everybody.
It can't be sine because it has a hypotenuse. It doesn't have a hypotenuse.
Oh yeah, how do we calculate the sine of an angle? It's the side that is opposite divided by the hypotenuse.
Oh.
So can I use sine here?
No.
No. What about cosine?
Tan.
Tan?
Tangent, yes.
Notice so has a hypotenuse, co has a hypotenuse. So we're dealing with tangent.
Oh. Get paid.
That makes some sense? Alright. So Matthew, the tangent of what angle do you think?
Okay, so, which number are we on again? 3? Okay,
90 degrees.
30.
Oh, wait.
Shh.
2 degrees.
never mind.
Me.
Is your name Matthew?
Sorry.
Not at all.
Yeah, your name,
Matthew, do you think anything that Kelsey might have said was right?
I couldn't hear her. She talked too late. Stop too quiet.
Matthew.
I forgot what I said. Oh, wait, I did.
10, 20?
I'm
I'm
23.
gonna pass.
I'm 23
so,
degrees. Well, my name is Kelsey and I think it's 23 degrees.
Matthew, what did she say?
her name is Kelsey and she thinks 30 is that.
No, I didn't know
No, everybody in this classroom heard it. Like, come on now. Tangent of
I
what?
think Chelsea agreed.
Okay. So I want y'all to look back up here and I want to ask this. Tangent of 23 degrees.
You want me to explain why not 90?
Sure.
Because you can't distinguish which one would be the opposite and which would be the adjacent.
That's a huge thing to notice. Have we ever dealt with the right angle or the 90-degree angle before?
No.
No, because can we have an opposite and an adjacent for the 90-degree angle? No. Trig ratios so far only work with acute angles. In later math classes you can deal with other angles, but in a geometry class, trig ratios only work with acute angles. So the tangent of 23 degrees. That's the only angle measure given. Is equal to what? The side.
Side opposite and side adjacent.
So side opposite divided by side adjacent.
30 and X.
So Brooke, What would be my side opposite here?
It would be, X.
X.
X?
Good job.
I hear someone saying, like they're not sure about that.
Kelsey.
No.
No, there's
I think it was Alana.
Mm.
Why are you going, you,
That's not an angle.
But that's also,
well, notice we want the side opposite 23 degrees.
opposite is 30.
The opposite is 30?
Yes.
Why do you say it's 30?
Because it's a cross.
What do you think, Brooke? Do you want to keep X or do you think it's 30? It's 30?
Yeah.
Because X is adjacent? Why do you say X is adjacent? It's not the hypotenuse, but it is next to that angle, isn't it? Okay, so 30 is here, and then you think of the adjacent as
Dude,
X?
get my shoe, dude.
What's up, Lori?
So do we have to find out what the X?
That's what we're about to get to in a second. What's confusing you?
I'm thinking the whole time that the hypotenuse is 23. So I didn't see the thing, like box, so it's confusing.
But notice here's the angle, right? The angle is 23 degrees. That's why we said the tangent of 23 degrees. Notice here's the right angle, and you even said it earlier, we don't have the hypotenuse. Remember, you said we don't have the hypotenuse, which is why we can't do sine or cosine.
Yeah, I know, but it was just, I was used to being on that side.
You good now?
It's gonna switch it up.
No, I'm
And then
not.
on one side is not gonna be
Okay.
hypotenuse.
But here's the thing, you have to remember the hypotenuse is always across from the what? Right angle. It doesn't matter how the triangle is set up, the hypotenuse is always across from or opposite the right angle. That's what you want to base everything off of. Now, we have an equation. Why are you looking at it like that, Alana? No reason?
How do you solve it? Right.
I want y'all to take 30 seconds, actually we'll go 45 seconds so you can get some discussion in. 45 seconds, talk about it within your group. What are we going to do to start solving that equation? Don't forget, you know the operations there.
I'm paying attention too.
You put this way now. You're not even trying to reflect, you're trying to copy someone else's work. That's a 0. Then maybe you should take those 10. Reflect on it at home. Need you working on this. Oh my God, come on, get to work. We got 30 more seconds, or 20 more seconds. What's the plan? How are we going to solve this equation? Yeah. What have you been doing? What have you been doing? Look at that equation. You have no clue what to do to solve that equation.
I would say multiply.
Why would you say multiply? Oh, it's the inverse of division.
Yeah.
Sounds like a good plan. Is this it? Thank you. Thank you. Thank you. Alright. Gabe, did y'all come up with any kind of plan about how to solve this equation? Huh? None at all? Looking at it now, it's still nothing? Hold on one second, just because I've had you talk several times, I want to give other people some chances to talk. Brandon, what about you? Did y'all figure out anything about how we might solve this equation? No idea? Did y'all actually talk about it?
No.
Like, how are y'all going to learn or figure anything out if you're not even trying to talk about the math? I'm okay with you struggling if you actually talk about it, but you didn't even try. Brooke, did y'all come up with anything? Okay. Potentially we could use the Pythagorean theorem, except how many sides do I have?
2.
We don't have the hypotenuse. Do you even know what the base is? So So how many side lengths do you actually have on this triangle? One. Can you do the Pythagorean theorem with one triangle? On one side. I need y'all to look again. I asked you, how are we going to solve this equation? We have a trig ratio on the board. We're trying to solve that.
Dude, shut up.
Say again. Yes, you can. There's only one variable. I can solve this.
I know.
All right, what?
Change to one, change to That's delta.
So, hold on to, and I want to point this out. Hold on a second. All right, I want you to say a really important thing of what you just said. We did something yesterday. So if we had taken notes and looked at it, what did we do yesterday?
You didn't even get no.
We multiplied by 10.
Oh, God.
And Jalen, I believe you brought this up earlier. You said we would multiply. Why did you say in your small group we should multiply?
Because the opposite.
Because it's what?
Yeah, opposite.
Not the opposite.
Inverse.
It's the inverse of what?
I barely.
Of division. So if I'm going to multiply, y'all, I'm teaching, pay attention. If I'm going to multiply, because it's the inverse, it's going to undo division, what am I going to multiply by?
The same thing.
10. No, 30.
23.
Say again, Kelsey. Kelsey said X.
We did X.
Because what am I dividing by?
X.
X. And multiplication is the inverse of division. I need to multiply by X to undo this division. We did 10 yesterday because what were we dividing by?
10.
10. Right, yesterday, so to draw a parallel, I need you to notice, I believe we did the sine of 34 degrees was equal to X divided by 10. That was yesterday for number 1. I am dividing by 10, so to undo that, I multiply by 10. Notice I am multiplying by what I'm dividing by to cancel it out. So here, when I'm dividing by X, I need to multiply by X. What is X divided by X?
X.
1.
Okay, but I need to do properties of equality. So X times the tangent of 23 degrees. So, notice X times the tangent of 23 degrees is equal to 30.
Oh, man.
Have I solved for X yet? Am I done?
No.
No. I'm almost there. I need what X is equal to though, so how am I going to do that? Think about it. What's there? What operation's there that I need to undo?
Divide by X. You gotta get.
He said subtraction.
Hold on. I need y'all to look again. What am I trying to solve for?
30.
Trying to solve for X.
Okay.
Get S by
So what do I need to get rid of?
10.
The tangent of
Dude, shut up, bro. You just screaming stuff.
So what do I need to do?
Divide by 10.
Notice what's happening. They're being multiplied, so the inverse would be notice what is anything divided by itself? 1. Tangent of 23 divided by the tangent of 23 is going to be 1. And so X is equal to, no, X is equal to,
30 divided by 10.
put it in your calculator. I don't know that off the top of my head.
Wait, what you say?
What is it?
No, no one should know that. It's an irrational number. Pick up the calculator. What?
30 divided by 10. So,
That's because it was the side opposite the 23
Triangular numerical.
divided by the side adjacent.
Wait, man.
Okay?
I got 18, this one 8, 9. 9. Y'all do something wrong.
I think someone else did. Actually, let me see something real quick. You gotta make sure it's not in radian mode.
oh, shoot, we forget about this.
Shut up.
Try it again. Okay.
Oh.
I got this.
Yes, ma'am.
Stop. I got 7.6756.
All right. So coming over to here, what is x equal to? 70.675. Okay. Really quickly, I need y'all to look at this. Yeah. Really?
That's why y'all didn't know. Y'all need to
Like,
stop
stop
playing.
goofing off. Pay attention, try to learn something. So I want to point this out. The way we got this 70.6756 is because we set up a ratio of the side opposite 23 degrees divided by the side adjacent to 23 degrees, correct?
Yes.
Okay, I want you to take the original 30
Okay.
and I want you to divide it by the 70.6756. Figure out what that decimal is.
70 point.
Notice this was the side opposite. 0.42.
4.75.
Okay,
Only 4 decimals.
now, it's okay up to this point, that's fine. I want you to look at this ratio again. When we divided it, it became this decimal, correct? Well, wasn't this ratio the tangent of 23 degrees? Isn't that where the ratio came from? Put the tangent of 23 degrees in your calculator. What is the decimal for the tangent of 23 degrees?
0.424475.
Yeah.
Stop playing.
Wait, so we got the same thing? Because remember, hey listen, these are trigonometric, what? Ratios. It doesn't matter how big the triangle is, if they have the same angle measures, the ratios are the same. That's what we're using to solve these triangles and to solve for these unknowns, is that, can you please stop talking and listen? Is that the calculator knows what the ratio is supposed to be. I need you to hear me again on that. These ratios are not changing. It doesn't matter how big or how small the triangle is, the ratio will always be the same. And so the calculator knows what this ratio ought to be, so that when we solve this equation, we can figure out what x is so that we have the right ratio. That's what's happening with these trig ratios, is when we go through that solving process, we are finding the value of x to get the right ratio, because that ratio will never change based on that angle. So you have to start by setting up your trig ratio. Then you solve that equation for your variable x. It does not always have to be this complicated, because I will point out, there was an easier way to do this problem. If this is 23 degrees. Anybody know what this angle up here is?
60.
67 degrees?
Move, man. 67.
You don't have to write this down, but I do want you to see this.
Why did you get 70?
Because what do these angles have to add up to be?
180.
Well, all three of them is 180. These two have to add up to be 90. Now if I look at the tangent of 67 degrees, what's opposite the 67?
X.
And then the 30 is my adjacent.
Uh-huh.
Now what would I have to do to solve that equation?
Multiply by x.
Multiply by 30. Boy, boy.
Remember, multiplication is the inverse of division. Notice how I've already got x on its own?
Oh.
What's 30 times the tangent of 67?
Did you just say 1?
Okay, go to your calculator. What is tangent? What is 30 times the tangent of 67? 30 times the tangent of 67.
Not 5, bro.
Wait, 70.675, like the same as this one?
Dude, shut up, man.
So tell me, was this easier or was the other way easier?
That other way.
This one was a lot easier, wasn't it?
Oh, let me write this down now.
You want to know why this one was easier?
Yes.
How did you plan on doing
You
this?
told me you gotta erase all this stuff.
Where was the variable? No, you don't have to erase it all. That's all correct. What was in the numerator here? Our variable, right? If we did it the other way, where was the variable? In the denominator. I am always going to do my best to set it up so that the missing side is in the numerator. You can't always, but I'm going to do my best to try to make sure that that missing side is in the numerator. So I'm going to pay attention to that. Now, can we solve it like this still?
No.
Yes. So don't be scared of it, but I'm always going to look to find what makes my life easiest.
So,
The second.
how many points did you get for this?
On my ground.
Huh?
How many points did you get?
Marshall.
No problem.
Well, it depends on, like, you would have to show me, so like, tangent is 67. You would need to identify the opposite. You need to tell me that's the adjacent, set it up, and then solve it. That would be a 5.5 or so. It would go into extra detail of tangent, so like starting out saying tangent of theta is equal to side opposite divided by side adjacent. That's, and then writing this equation is how I get to a 6. Like showing that extra detail and labeling it on the triangle.
So wait, how did for the other?
Well, x is this, right?
Right, so how do you get that answer from tangent equals
We're type 30 times tangent of 67 in. Did you do that?
No.
Because those who did got the same exact answer. That was my point.
So how did, what?
You already did it once. You don't have to do it again. Okay, let me clarify something, y'all. You already did it once solving this equation. My point was, if we had found the other angle and set it up this way, it would have been easier to solve. That's all I'm saying.
Is this what we do?
Yeah.
Okay.
Yes. Because you had to solve this equation. You got that equation, the tangent of 23 degrees equals 30 divided by x, then you solve that equation for x. Alright, at this point, I want y'all to work on numbers 2 and 4 solving for x. When you finish that, work on solving in numbers 5 through 8. Remember, whatever you don't finish in class today is what you have to do for homework before Friday.
Well, you talking about this whole
We're
thing?
going to talk about it some more. I'll explain a couple more things once we finish through 8. Yes, we're going to talk about those as well. Actually, we'll get to that in a minute. Just complete 2, 4, 5, and 6. I'm going to print some stuff out, and then we'll get going from there. I will explain more in a second.
You're getting me angry, bro.
70 point whatever. What x was equal to? X equals 70.
He's so low.
Well, remember, I was just showing you that that gave us the right ratio for the tangent.
I'm not gonna
Remember,
this fuck you, oh God.
well, you have to pay attention to what angle you're dealing with and which ratio you have. Huh?
No, I'm talking about like, you start with that.
Yeah.
So we have opposite, we have adjacent.
How you have a D,
Do
man?
I have opposite, adjacent, or hypotenuse?
Why you do this out here, that walk?
You're trying to memorize instead of focusing on opposite, adjacent, and hypotenuse. Because if you have opposite and adjacent, which ratio are you going to use?
It's a 60 on
Okay, if you have adjacent and hypotenuse, what are you going to use?
He's stressed out. He have a hard time at home.
The COS? So that's just an abbreviation. It's cosine, is the full word.
So we already know what hypotenuse is. It's not tan. 2 is not tan. Bro, tan, bro, what are you doing? Are you just underlining it? Are you just underlining it, bro? No. I'm not bro.
Yo, put it away. You're supposed to be working on Trig Ratios.
I'm waiting for you to come over here and start turning in.
Two, bro.
Oh my God.
You better get number 3 off the board.
How you do this, bro?
I don't know who it was. Ask him.
Alright, so number 2 is tick.
Okay, so it's either sine or
Cosine. It's either sine or cosine. So we got the high time. No, it's not.
half. It's cold.
Oh, bro.
Alright, you got
So opposite.
So the X would be adjacent.
4 is not tangent.
We weren't supposed to be on 2.
Look, I put sign. I mean sign.
I ain't too cold.
And then the bottom one would be
That's the wrong person. You know how to do no 2, bro?
Dude, y'all going
You go pay them. As long as I got a dick.
It's 48.
Hi, Chris.
Well, no.
I don't need nothing.
You don't got nothing?
I got everything I need. Everything I need. What?
Under the criminal tree, when you gonna open it, don't be upset.
It's right here.
And that Christmas tree, you gonna see us now.
Okay. Okay. Yep, you can use whichever angle you want if you know both of the angles. As a computer. Number 2, which trig ratio should we use? But if you do 34 degrees, that's this angle, right? What is x in respect to 34 degrees? Right, why not just use sine? Well, what do these angles have to add up to be? If that's 90, what do these have to add up to?
Okay, criminal tree, you gonna see on first.
3 of them add up to 180, but that's 90.
They're on my purse.
But notice, like, you already, you have that 56, right? Sine of 56. How do we calculate sine?
Yeah, he's a strong person.
You don't look at it.
Yeah, he's strong.
To pick up something this period? Maybe you just head down there and see if there's something you need to get from the office. Alright, can I grab everyone's attention? Let's talk just briefly about this one, because some of us have already started engaging and struggling, and that's good. Again, please hear me very clearly. Struggling is good, not flirting, but struggling is good. Which trig ratio could I use on number 2?
Cosine. Cosine.
Cosine of what? Hold on.
Bro,
no, it'll be 34.
So, here's 34 degrees up here. How do we know that's 34?
34 plus 56.
Right, remember, here's 90 degrees here, so the other 2 angles have to add up to be 90, right? So that's 34, that's 56. So, if I'm going to use cosine, how do I calculate cosine?
Adjacent divided by hypotenuse.
Adjacent divided by hypotenuse. Cosine of 34, what is adjacent to 34 degrees?
Good movement.
56.
No.
No.
12.
Adjacent.
Okay, so, hold on.
No, it'll be 8.
I need to pause for a second here, because this is why I recommend that you write out this statement before you start plugging stuff in. It's the side adjacent to 34 degrees. Why do I point out that it's the side adjacent?
Because
So, angle measure.
Because we don't want an angle measure. Some of y'all are saying 56. Is that a side?
No.
No. So, is the side adjacent to 34 divided by? Why are you talking while I'm going over it? If you have a question for the whole class, cool, but like, I'm going over it. Just stop for a second, pay attention. Divided by what? Hypotenuse. So notice cosine of 34 degrees would equal.
X divided by 12.
Now, is that the only way to solve this?
No.
Did anyone try a different ratio?
B.
Kelsey?
Sine.
Sine of what?
56 degrees.
Would equal what?
Is X divided by 12.
Is that true? Sine of 56 is x divided by 12?
That's the same.
So let me ask you this, will it give us the same answer?
Yes.
Hopefully. I mean, sine is what divided by what?
X divided by,
Opposite divided by hypotenuse. So I mean, that might work. So let's say this, I want these three groups over here, I want you to work it out as sine and figure out what x is. These four groups over here, I want you to work it out as cosine and figure out what x is. So if you are on these four groups, you're working with this equation. If you're on this side over here, you're working with this equation. Let's figure out what x is.
Can you turn the light on? Cause nah, I'm gonna.
Wouldn't you what? Being so jumpy. Come on, which ratio do we have? Sine of 56 was equal to x divided by 12. That's the one I asked y'all to use. How would you solve that equation? But look, you're trying to memorize what I did with the only one. Look at that equation.
I didn't say memorize.
But no, but you're trying to just compare it to the previous one. I want you to look at that. You know how to solve equations. A little bit, but not much different. Look at that equation. How would you solve that equation in front of you? Multiply by what? Multiply by what? Okay.
12.
Multiplication is the inverse of division. So it would cancel out that division maybe?
You actually need 34.
12 divided by 12 is?
Oh, no,
So
we got
x.
67 from. What's
No, 1x. Remember it's 1x, but I still need to multiply that to figure out what it's equal to.
No, I'm talking about, I didn't know how you got 67 now.
12 times.
Yeah, I know now, fool.
Did we figure out our answer?
I got it, folks. I got it.
Oh,
Huh? We're not solving the triangle right now. We're just asking you to solve that equation. Well, then move to this
I know
one.
now.
No, that one. Move to these four. Oh, don't worry about that. I'm going to take that off. Why'd you do 12 divided by the cosine of 34? You have the cosine of 34 degrees is equal to x divided by 12, correct? What do I need to do?
I'm gonna show you the picture. When I see they do this, when I see it,
Pay attention to how the equation is set up. Thank you. Thank you. Thank you. All right, London. I know I talked to your group. I didn't get to talk to the other groups on this side much. What did y'all get when you solved this equation? What'd you do?
hold on.
You don't just say that. You gotta tell me like how you solved it.
Yeah, don't just tell me the answer. What did y'all do to solve it?
We multiplied by 12 on both sides.
Multiplication is the inverse of what? Division, so the 12s would cancel, creating a 1. And what is 12 times sine of 56? What'd you get in the calculator?
9.948.
9.948.
That ain't it.
45.
45?
That's hard. You're supposed to do code.
Okay. So that's what this side got. Over here, Gabe, what did y'all do to solve this equation?
Same thing.
Same thing. Well, my bad.
When you say the same
We
thing,
multiply 12 on each side.
so you multiply it by 12 on both sides? So 12 divided by 12 is 1. So what is 12 times the cosine of 34 degrees?
9.94845.
It was the same answer?
Yes.
So I need you to notice, does it matter which angle you use?
No.
It doesn't. You use which angle you want. It doesn't. Does not matter which angle you use. You just have to use the correct ratio for that angle. That's it. And then you're going to use inverses to solve that equation. I want us to get a little bit more practice in. Hey, listen. I'm going to give you all 10 minutes to work within your small groups to work through as many of these equations or these triangles as possible. Don't worry about solving the triangle. We're just going to solve for x for now to get that practice in. We'll have more practice later. So just solve as many on this page as possible, solving for your variable x. Okay?
I'm sorry.
Just out of the calculator.
No, there's 5.
These are trig ratios. Sine. It's literally just putting that to the calculator. You're just solving for x. Yes. Hey, by the way, y'all, you may want to get out a separate sheet of paper because this could get really crowded really fast on that page.
Y'all tired? Oh my bad.
That's how I thought my daddy was doing. I ain't got a sheet of paper in here.
Where you at?
Sounds like you left it probably.
I ain't no sheets of paper in here, fool.
Gentlemen, I need y'all doing some math. If you need paper, there's paper up on the Student Work Center. You go get it.
He need it. You need it. We need it. I don't need that.
One of you two stop talking and go get it.
What kind of truck, Tyson?
Where's my phone? Where you?
I thought we already did it before.
Gabe, did you not give Tyson a sheet? Time out. Have you talked to your group at all? What number are you working on? So you're looking at the cosine of 48 degrees is equal to, you said x divided by 125? Okay, now I will say this, that's x star, don't forget that would not earn full credit on explaining where this is coming from. Okay, so opposite of 48 degrees divided by adjacent to 48 degrees, perfect.
Stop talking.
Wait, opposite divided by so,
Let me guess. So with your daddy.
say again? Okay, cosine 48 degrees equals x divided by 25. Cosine is adjacent divided by hypotenuse, right? You good with that? Okay.
So wait.
What are we trying to do? We're solving for x